To understand horsepower, you must understand the term work. Work is defined as the operation of a force over a specific distance. For example, lifting a 1-pound object 1 foot. This is the standard measure of 1 foot-pound. Work can be performed in any direction. Pushing a stalled car, for example, or a pump pushing water through a level pipe are both examples of work. The rate of work, or how much work is done in a given time, is called power. To make power calculations, you must know the time it will take to perform the work. One equation for determining power per foot-pounds per minute is as follows. Pounds in foot-pounds per minute equals head in feet times the flow rate in pounds per minute. You will often work with measurements of power expressed in horsepower, which is related to foot-pounds per minute by the conversion equation. 1 horsepower equals 33,000 foot-pounds per minute. When doing power equations, you must first convert the measurements of head, flow rate, and power in the proper units. Power must be expressed as foot-pounds per minute, not as horsepower. Pressure and velocity heads expressed in feet of head, not pounds per square inch of pressure. Flow rate must be expressed in pounds per minute, not gallons per minute. The power calculated in foot-pounds per minute can be converted to horsepower by dividing by 33,000. The conversion equation is 1 horsepower equals 33,000 foot-pounds per minute. This is called water horsepower and is represented as water horsepower equals the flow rate in gallons per minute times the total head in feet divided by 3,960. We will discuss calculations of pump horsepower and efficiency made in conjunction with water transmission, treatment, and distribution operations. The selection of a pump or combination of pumps to provide an adequate pumping capacity will depend on the flow rate required and the effective height through which the flow must be pumped. Effective height is defined as the total feet of head against which the pump must work. In our first example, we have a pump that needs to pump 2,000 gallons per minute against a total head of 20 feet. What is the horsepower required? Horsepower is foot-pounds, so we are going to convert this to foot-pounds. 20 feet times 2,000 gallons per minute times 8.34 pounds per gallon equals 336,000 foot-pounds per minute. Divide by 33,000 to convert to horsepower. The minimum horsepower required for this pump would be 10.18. This number is correct only if pump efficiency is not taken into consideration. That's because no pump is 100% efficient. In the actual workplace, you will need to divide this number by the pump and motor efficiency to determine the total horsepower required to be installed. More often than not, a slightly higher horsepower pump will be used or recommended. Say we have a pump that is pumping 450 gallons per minute against a head of 50 feet. What is the horsepower required? We will need to convert to foot-pounds. 50 feet times 450 gallons per minute times 8.34 pounds per gallon. So now we have foot-pounds, and that is going to equal 187,650 foot-pounds per minute. We already know that 1 horsepower is 33,000 foot-pounds per minute. So the 187,650 foot-pounds per minute divided by the 33,000 foot-pounds per minute per horsepower is going to give us 5.69 horsepower in this mode. Again, this example does not take the pump efficiency into account.